Well, hi, good morning. Thank you so much for joining me in my shop. Today is January 21st, 2025. In front of me, we've got an amplifier. This is another Heathkit product, I believe. Yeah, Heathkit solid state stereo amplifier model AA14. And it has various inputs you can select. There's a volume control. This is probably a balance thing happening here. Headphone jack right in the front. Speakers off, pull. Bass control. Oh, okay, so this is a dual control. So this will turn the speakers off if you want, or control the bass, control the treble, and turn it on if you want. Okay, that's a model AA4. All the different inputs. Quite a bit of speaker outputs here. No, just these left and right. Actually, it's all the way around, left and right. All these screws here. Well, they're just holding the block on. Wow, that's a little overkill there. Grounding terminal, switched and an unswitched plug on it. Okay, let's take a look at the fuse. Let's see what we got here. It's a slow blow fuse. Three-quarters of an amp. And it's definitely not blowing. This is slow blow, three-quarters of an amp. Almost certainly the original fuse. There we go. Okay, well, I think all that's we can do with this is power it up and see that it works or not. Does it have an output? No, it just has the speakers. It doesn't have an output, you know, like a line level output. Okay, well, we'll give it a go. For all I know, this works fine, and there's nothing wrong with it. I got no idea. Well, I need an audio source to test this amplifier. See, I have my shop speakers connected to it now. So I'm going to use this as the audio source. I picked this up a year or two ago. I have to tell you, this is not a pleasant radio to operate. But I think I can pick up some FM with it. I thought I'd tune it in. You can watch what's involved in it. It's only got one knob and an on-off switch. One knob does it all. So see the red? Watch the red there. And I'm going to move it down here where it says AM. Wide FM. STD. Okay, now we're going to go back up here. Tune it into you see why this is not a great radio? Wait a minute, isn't that 91? Okay, turn the volume down. This is what I got to do to turn the volume down. I'm down here on the speaker control. Okay, how come I'm not hearing FM here? Because I've got it set to the wrong kind of thing. So, I should not have put this on video, obviously. Isn't it 91 point? I thought it was 91.5. There we are.
So about 2 months by the end of
April. Okay, got it to work.
Back in jail again. She had again.
So that's what I'm looking for. I'm looking for a station with just audio on it.
She's sitting in jail now, awaiting.
And I have this cord.
What is it? This goes back finally to the thing that I started out with, which is.
Doesn't it cut the audio off? It does not. Okay, I'm going to cut the audio off. case you can't tell what I'm doing, I'm pushing this in, and then I can rotate it and it'll move the selector point around. And then what was I going to do? I was going to turn the speaker off. There, speaker off. So the sound is coming out on the headphone line, headphone level, and we'll plug it not into phono. Let's plug it. Let's start with auxiliary. We really only need to test one of these. My guess is this guy works. Okay, so that'll be the input and the output taken care of. Wow, that antenna is stiff. Felt like it was coming apart when I lifted it up like that. Okay, one last look at the speaker connections. Oh my god, this antenna's flying around now. Now it's decided to get loose. Yikes, I don't know if I can have an antenna flying around in my shop like that. We'll leave it like that. I picked a battery operated device also, so there's no ground issue at all. That's what I'm up to here. We'll plug them in. Let's rehearse the controls. Whack the microphone there. Okay, first the volume. Volume's down. It's balanced, what I think is balanced. Oh, you know what? This could be left and right volume. Don't be fooled. I bet you it's left and right, and then you balance it this way. I'll bet you that's what's going on there. Okay, so volume down. Speakers, well, we're going to want them on. So this goes in. And then we're setting this to auxiliary. That's where it is. Okay. I think we're just about ready. Let me tip this up. Hey, there was a good move. And somehow the speakers come back on that little radio. How did that happen? And the antenna went wild in my shop, which really got me freaked out. Don't run out and buy this radio, frankly. I would not in any way recommend this thing. So I'm going to turn the speaker off. There, okay. It's not going to sit up like that. And the antenna's flying around again. Oh boy. This was not a good choice to bring this in here. Okay, now I know better. Just sit there. Okay, I think everything's ready. Everybody back up. Stand back. So we pull on. So it's off right now. So we apply some power. And we'll see nothing happens. That's good. Once in a blue moon, the off switch is broken and it's just on all the time. So I want to find that out. Okay, I've turned the power off. Pull the switch on. I'm going to turn the power back on. It's going through the dim bulbs for whatever that's worth. Okay, so I heard a little crackling out of this speaker and the hiss out of that one, and now nothing. Well, that was short-lived. The hiss sounded like radio hiss. Let's make sure the radio is still radioing. I'm going to turn the volume up on it. What happened to the FM station? How come so weak? Well, we were listening to this just a minute ago. Well, this is not working out worth a hoot, so I'm going to find another source, because this has just turned into a complete disaster. You know, I do these videos live. You're seeing what happens, so sometimes things don't work out. But we are hearing the amplifier at this point, though. Okay, let's just pull this input out. I'm a little worried that hiss didn't go away. Let's get this right out here before. Sooner or later that antenna is going to contact something, and I'm going to regret it. So, yeah, bad. That was a bad choice. Okay, learn by doing. What's with the hiss we're hearing? Trouble. Speaker switch. Well, that's not a good sign at all. A hiss like that. Let's try these different volume controls. Well, I guess the hiss is not volume controlled. Yeah. It's got a headphone jack. I'm going to pop my headphones in there briefly. But chances are it's exactly the same output as the speakers. Let's see. Wow. I clapped my hands there not because I was happy, but because I put these on and I could swear I'm listening through a microphone. But no, it's not. It's just this thing. There's no microphone, of course. Well, now I have a vacuum tube shop here, and this is a transistorized device. The hiss is endemic. I've got no experience with this kind of stuff, so I'm going to stop for a bit and think. But I just don't think I'm going to be able to do anything with this. That's what I think. So I've been out of the shop here for about 15 minutes and come back, it's just hissing along. No surprise there. So, you know, I don't think I can fix this, but at the same time, I'm curious, and I would like to take a look inside this, and we'll just see what we can see. One channel's not hissing. I don't know. I don't know. So let's see. Cabinet appears to be held on by these outside screws. So let's take them off. So I'm guessing this is a kit that was built by someone in their house, not built by Heathkit. Heathkit used to sell assembled kits. You just have to pay them for the cost of the assembly, of course. But let's take the lower ones out. And over the years, I've built a number of Heathkit things. I have a electronic digital clock. It's up beside where my bed. Built it when I was in grade 11. That would have been in the early 70s. And it was a digital clock. Almost nobody had electronic digital clocks at that time. So it was pretty impressive. It cost me $98, I'm pretty sure. It was a lot of money. But I wanted to have that digital clock. So I built that thing. Like I say, it's up beside my bed. It still runs. When it's trying to show the number 1, it flickers a bit, and sometimes you can't show a number 1 for some reason. I don't know why exactly, but it's been running since the early 70s, right up until today. I don't think I've ever done anything to it whatsoever, except set the alarm in it. Didn't I not get all the screws out? What happened here? I did not get all the screws out. What am I doing? It's because I'm talking. There we go. There we are. So I got the big power supply. We've got diodes down here. One of them looks fried, in fact. One of them looks bad. These are all the same temperature and they're cool. There's no heat in here. I'm feeling some heat though. This is still plugged in. Oh, Jim! Jim, man alive. It's warm right in here and here. So these two areas that they have the same temperature. So okay. It's got this protective plate here. I wonder why that's there. It's got a big resistor back here, part of the power supply. These wires look like they're coated with, I don't know what, something, mildew. Not that it matters. Okay, well, so what, so we've got, I missed this one. Yeah, there's no heat in these. 4 output transistors. You know, these two look the same, and these two look the same, but all 4 of them do not look identical. Great big filter capacitor. Big fat filter capacitor. Can't do much with this board the way it is. And it looks like we can take this plate off here. You know, these screws might go to nuts, or they might be metal screws. I'm going to take a risk. They are metal screws. Take this plate off. Well, I'm not quite sure why this plate is here. It's covering this big hole here. Covering over this area. So you can look at, and you know, in an amplifier, the front end of the amplifier is very sensitive to any kind of interference or hum or noise or anything like that. So that could be what's going on here, because, you know, here's where the input's coming in, especially the phono input. So maybe they're shielding this area from everything else to reduce noise. I see there's a lot of spots here with nothing in them. So that's a little weird. Oh, now I'm getting a phone call. Yeah, okay, phone call was a fraud call. I didn't answer it. Here in Canada, our phone companies tell us if they think the call we're getting is fraud. We can look at the phone and you get the phone number, and below it says likely fraud. I just don't answer those at all. Maybe we can lift the circuit board. So I see there's some nuts here and nuts here, and I can see a bit of a plate here. So I think there's a plate. Again, probably another plate to try to stop this part from being interfered with. 1, 2, 3, 4 outside screws. You think if I do those screws and just lift this whole board right off? All these wires here. There's a bunch more down here too. Well, you know, the amp doesn't work. So what harm can I cause here? And now it's time to talk about the weather. It is cold here. Really cold. This morning when I got up, I think it was minus, oh, I can't remember now, around minus 20. That's cold. I see the guy has etched, scratched, or penciled in a couple of T and S over here. T and S. Okay, board, do you come up now? Is that all it took? Oh boy. Not that simple. Not that simple. Hey, you know what? I never turned this over. Did I turn this over? You know, look at the other side of it. Oh, there we are. Well, you know what we could do? We could take this bottom plate off and get access to everything. That's a much better way to go than trying to loosen it. So I'm going to stop the video. I'm going to put these screws back in. We'll take the bottom plate off. I should have done that in the first place. And carry on. Okay, let's peek inside here. So lots of electrolytic capacitors in here, big ones right away. These could be for the output of the where the signal's on its way to its transistors. It looks like we have some heat-sensitive components here. I think these are intended to detect a problem. I'm not sure of that. So if this thing overheats, this will open or something of that sort. I don't really know. I'm not Mr. Transistor. I'm not Mr. Transistor. So, but I did study them in college, so I'm not totally green to the situation. So nicely laid out board, all nice and clean. What would I be looking for in here? I got no idea what I'd be looking for. You know, making a hiss. That's some kind of component problem. It doesn't mean the component's going to be burned up or have any kind of external look at all. Everything looks perfectly fine in here. Looks really great, in fact. The electrolytic capacitors, could they be responsible? Offhand, I don't think so. I don't know how they would generate a hiss. I don't know. Could be we've got an input to a transistor and the input impedance has gone way high. I don't know. It was such a nice, clean hiss. It sounded like that FM type of hiss. I don't know. What am I to do here? So there are two amplifiers. Can we see them separately? Sometimes they do a mirror image. Other times they make them identical. So for instance, if you look here, you see big, medium, 2, big, medium, 2. It's the same arrangement here all the way through here. It's all the same. And we get up into here, and it's not the same through here at all. I was hoping there'd be like a dividing line here, and they could say this is the left channel, that's the right channel. Doesn't look like that's the case at all. And there isn't. Sometimes the two channels would be arranged this way, so you can look at them and see them. That may be the case here. You can see a transistor, 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 just straight down the row here. We can see where, maybe we can see where the output transistors get their feed from. And they're going to get it from a driver transistor, which I don't see. Usually it's a little bit of a bigger transistor. Oh, these guys right here. These guys on the heat sinks. We could look for shorts. Perhaps there's a short in one of these transistors. And the opportunity, talking about shorts, pretty close right there. Right there where the wire's coming out of the transistor. But I don't think it's actually short. Let me just take a look. Here. No. No, it's just very close. We'll just make it a little bit less close. Here. They're not touching. Nothing was touching. Would that make a hiss anyway? I don't know. I don't know where a hiss comes from. That's an interesting question in itself. Hisses can occur in tube equipment, but not that often. Not often at all. But we know the transistor circuits are always hissy. And I think personally it has to do with the heavy currents that are flowing in transistor circuits as opposed to tube circuits where the currents are very, very low and the power is coming from high pressure, high voltage. Whereas here the power is coming from high current. And you can imagine a high current through a resistor Even that can cause a hissy sort of noise, I think. Well, that's an interesting question on many levels. Where does the hiss come from? I'm going to investigate that a little bit. Okay, I thought I'd ask the new brain in town. This is Microsoft's Copilot. Wow, what I should do about this. So this is my question I asked. I'm working on repairing a transistor amplifier made from a Heathkit. It's a stereo amplifier model AA14. I've operated it, and one channel has a loud and steady hiss that does not react to the volume control or selecting different inputs. What might cause such a hiss? And here's what ChatGPT says. Or actually, this is Copilot. A loud and steady hiss in one channel of your Heathkit AA14 stereo amplifier could be caused by several factors. Here's a few possibilities. Faulty transistors. One or more transistors in the affected channel might be faulty. Transistors can develop noise issues over time, leading to a constant hiss. Bad capacitors. Electrolytic capacitors, especially in the signal path, can degrade and cause noise. Replacing old capacitors might help. Resistor issues. Carbon composition resistors can become noisy with age. Checking and replacing any suspect resistors could solve the issue. Grounding problems. Poor grounding or a ground loop can introduce noise into the signal path. Ensure all ground connections are solid and properly connected. Of course, this is a different kind of noise they're talking about here. When I say hiss, that's different than this kind of noise. Power supply noise. Issues with the power supply, such as a failing filter capacitor, can introduce noise into the amplifier. Checking the power supply components might be necessary. You'd hear that in both channels, wouldn't you? Interference, external interference. So we can eliminate some of these possibilities right now, like interference, no. Power supply noise, no. Grounding, I doubt it. I'm going to whack this a little bit with a stick and we'll see what happens. Resistor, possible. Capacitor, not likely. Faulty transistor, most likely thing is this. I think this is the most likely thing. That's my opinion. So here's the last thing. Given the age of the Heathkit AA14, it's likely a combination of these factors. A thorough inspection and testing of the components in the affected channel should help identify the root cause. If you need more detailed guidance, feel free to ask. I do feel free. Okay, so I didn't really learn anything here. It's kind of sending me in the same direction that I'm already in, and that is there's a bad transistor in here. Let's try the poking thing. It's really not likely to help, but we'll try it. So the poking thing is based on the idea that there's a mechanical issue. It can still be inside a component, like a contact or lead contact inside a component. Wouldn't create this kind of hiss though. So we need to get this guy hissing, and then I need to whack it with a stick. Here's the stick. And the volume control is down, and the power is off. I'm going to turn it on. We're going to apply the power. We're applying it. Hiss. There's the hiss. Sounds just like an FM radio. Oh! What happened there? Oh! What's happening? It's coming and going. That's an interesting sign. Okay, coming and going. Was that like a startup thing with voltages going up and down, or? And it's not volume sensitive. Ooh. No, that's another kind of. Not volume sensitive. Doesn't care about the input. Tone controls having no effect. Okay. Let us begin the poking. First of all, it's coming out of this channel on my left hand, and that is going to be from this channel here. And this channel is getting its signal from over here. Come on, really? Can't be that easy. all gone now. Cold solder joint. So the hiss may be disappearing, the whole signal may be disappearing. Is this a socket? These transistors are socketed, or are the wires coming through and soldered? I think this might be a socket. If this is a socket, then I should pop all those transistors out and back in, especially with what's just happened here. Can't replicate the effect. Oh, I can. Let's do what I said. We'll check if these are really plugged in transistors in sockets. Ooh, doesn't look like it. They're screwed in here. Could still be plugged in. This is on a great big metal frame of some sort. What is this? Same thing on this one. So obviously there's a pair and a pair. Okay, so I don't want to do these screws. I don't want to. It's just going a little too far. They're screwed in, so you know what I can do is this is kind of crazy. I have no idea if this is really an effective thing. The set turned off. I have no idea. I don't know. Is this going to do it? I'm going to try to mechanically work assuming these are plugged in. I'm trying to mechanically work the, you know, where the transistor pin comes in. I can't imagine this is going to work. This is the one that's acting up, so it seems. Could be a cold solder joint, especially this one here. Oh. That's quite loose. So this looks like it's supposed to be soldered down onto this bracket. So like this one here is soldered right down onto the bracket. In fact, there's a piece of bracket here that's lifted up and over. It must be the same thing here too. So pretty hard to see how that's not soldered to the bracket. So I've wiggled these ones. I don't want to wiggle too much more. It's kind of like a fat chance that's going to make any difference. But just touching it did. And the guy's written Q3, Q, looks like 5, Q4, and Q, I don't know what that is, 6 on there. Okay. Well, we can leave it like this and fire it up again. Yeah, just turn the power on, Jim. Okay, well, we're certainly hearing a hiss. Nice and clear now. What happened there? So I touched this, but I really didn't. So I'm using a stick with very little momentum in it. It looks like I'm whacking the heck out of this, and really not. I learned this in college. Nothing's happening. It seems like it's all past the volume control anyway, because the volume control... Oh, I can hear a hiss come out of the other speaker now, up this way, but that's a proper hiss. This is an improper hiss coming out of here. Let's go back to starting again, because this kind of worked out. So we're coming from here, this one. This is the signal wire. Ooh, what's it going in there for? What's in here? Seems to go in there. This is the power supply. Well, maybe it's picking up VCC or something like that. We'll just work a few parts a little bit down here. Okay, this is the guy who seems to be implicated. Whoop, what was that? It changed when I wasn't doing anything. Getting no responses now. It was all coincidence before. Just trying to put any kind of mechanical stress on this that I can come up with. That way, even though, yeah, I know it's this channel. I know it's this channel. So another thing would be to listen further up. I take my signal tracer and listen, like I'm listening to this transistor here, and just seeing if how far back the hiss goes. Could be one of these output. Could be the output transistor itself. Everything else could be perfect. And what about the other channel? We never did really hear anything come out of this. So okay, so we're gonna try that. Oh, I tried it with the radio I had. Oh yeah, that's right. Stupid radio. Let me get another stupid radio. Okay, just because I like the challenge. Here's another old radio, Grundig. You're listening to it. Dirt in the volume control here. That's what's coming out of it. Plug it in and see what comes out of it. This is a stereo. Oh, this is stereo. Let's try it. Well, I hear the other channel hissing, but I don't hear anything coming out of here. Oh! This probably isn't set right. Oh, sorry. What's this? Auxiliary stereo mono. There's two auxiliary switches here. Oh, the jack is broken here. Okay. Goodbye, Grundig radio. I don't get to operate these old radios too often, so I'm seizing the opportunity. Well, what about this? This should be enough to generate, especially if I put this on phono. Oh, that changed things. Volume's up full though. Okay. Phono input on the back. I'm not on the phono input. I'm not on any input. Jim. Come on, man. You know, it's just I have not had enough coffee again. We're going to put this in the phono. Well, I'm going to bring back the radio. Put this in the phono first. Do the finger test. Okay, there's no question this speaker up here, because I'm not touching. But the other one, no. So she's a mono amp at this point. Oh, there's a mono phono. Wait a minute, I'm touching, and I'm hearing it out of both. I'm hearing it out of the one channel. Oh, it's phono mono. This phono stereo. Okay, phono stereo. So the tip, ring, and can't remember. Tip, ring, I can't remember. Tip, ring, and the ground. So the ring is the right speaker in my shop, and the hissy one, you know what, you can hear that. So through the hiss, this is working. So the hiss is like on top of things, which means if you can get rid of the hiss, bingo. wouldn't the hiss be most likely to come from an earlier component and be amplified into what we're hearing now? Can a hiss this loud be coming from these output transistors? I don't know the answer, but if we come back here, I think I should listen to what is happening on here. Okay, coffee time now. Okay, I'm going to, I don't really want to listen to the hiss here. We won't be able to listen to the hiss coming out of the speaker. So I'm going to disconnect the speaker that's producing the hiss so we don't hear it anymore. Okay, now we can hear clearly the other channels making a buzz. Yeah, and that's just because this cord is hanging open here. That's what's happened. No problem. Okay, next thing to do, let's take these cords off so we don't hear that buzz. Okay, so we're going to use this guy here. Now this is like, old style tube radio testing equipment meets transistor amplifier. So I think I can just put this onto the chassis. I look carefully at the wiring in here. It looks like there's some grounds to the chassis, but what are you popping about? This doesn't usually pop like that. So this is a radio receiver and an audio amplifier. So we're going to flip it to the audio amplifier position here because we want to listen to audio. So now it's just an audio amplifier. Put the ground on here because I don't know what else to do with it, and it seems to be the right thing to do. Where can I clip it nicely? Clip it here. Now what we're going to do is we're just going to pick one of the three leads that are going to the driver transistor on the channel with the hiss. And we're going to see if we hear a hiss on any of these. I got my hand on the volume control here. You can't quite see where I'm going with it. It's kind of tucked down in there. Okay, this could make big pops. Who knows? I don't know what it's going to sound like. I can have the volume down on it. So that's one contact. Bit of hiss there. So the same wire on the other transistor, and they are organized the same. Actually, I can see collector, base, emitter. So this is the other channel. Volume down. Ooh, it's really hissy here. Okay, without changing the volume on the tracer. That's a lot of hiss. So this transistor has a little hiss there. This one has a lot. Come on, they must go like this. The channels must be organized like that. Let's try the next thing over. This will be the bass then. Ooh, so there's a voltage on it here. Silent. Bass over here. Silent. And the last one is the emitter. Silent. Silence. So what's going on here? So the channel without the hiss appears to have the hiss. Well, we can listen to the output transistors too and hear what each one of them is doing. Don't know which to touch, so I'm just going to touch them all. Hand on the volume control. Anybody see what I saw? Did anybody see what I saw? Okay, I saw something a little scary there. I saw the dim bulb light come on. maybe I briefly shorted this? Now I'm freaked right out. This goes to nothing more than a vacuum tube grid inside here. This is going nowhere. So there's no shortability through here. I must have briefly shorted this out. I don't see how. Okay, this is kind of scary now. You can see the dim bulbs too. Just a mild hiss there. Oh, jumper! What was that? It's just a loud sound, Jim. Just a loud sound. Let's try it again. Keep the volume down. Holy smokes! Oh, there's something about this I don't know. Let's take this cap off. I'm sure this goes straight. Look at it's shorting. Because this part's come loose. Well, that's not a good thing at all. That's not at all a good thing. Oh my gosh. Wow. Hey man, this is fun. Okay, I'm going to try to protect that my test instrument a little better. We'll carry on some more. Okay, so I'll put a little protector in there now so this can't short anymore. Pretty sure. And this outer cap, this just sits on here. It doesn't screw on or anything. Which is why I got some tape on it. Hold it on, but I'll hold it on. Okay, we're back in business. Back in business. Now, I was touching this lead over here, getting a great big kaboomy from it. Yeah, volume check. No hiss. A big hum from this one down here. Okay, starting with the humming one over here. Yeah, same thing. Shaky hands. A little bit of a hiss there. This one here. Okay, coming over to this one. A lot of hiss. So this one matches this one. No hiss. Sure seems the hiss is over here, but I had assessed the channel wiring as being here. Let's keep going, and on the volume. Hiss there, very little there. Ooh. And the hum there. So we found a hiss on this transistor and we found hiss on the output. The hiss we're hearing here is on the collector. Let's listen to it again. So we'll start with the emitter on the other side. Emitter. No hiss. Bass. No hiss. Collector. Ooh. That's the hiss. So the hiss is being either generated here or it's being presented here. So we'd want to move back further. Now, I don't have a schematic in front of me or anything. There's a lot of little transistors down here. And before I realized I couldn't identify left channel from right channel properly here, easily anyway. It looks all weird. So I could start listening to the transistors going back, but I don't know what I'm doing at all. Yeah, that's okay. So we'll go for the collector on this one. Yeah, see, Nothing there. I don't know what I'm doing. Besides, the signal's getting lower and lower and lower. The hiss might be so low as to not even be significant in this device, or not recognizable. I can't distinguish it from other hisses. Okay, I'm really not too interested in carrying this much further, because although I do have a huge stock of vintage transistors here, disorganized, but I have them. Trying to repair this properly, I think, is out of my bailiwick, for sure. Okay, I'm going to stop for a bit, drink some coffee, think some more, ponder life, watch somebody else's video. Okay, well, I left this running kind of by accident for about 20 minutes here, and I've checked. The temperatures are equal and even everywhere. There's nothing outstanding temperature-wise. So, what can you do? I can't do anything. So I'm not going to pursue this any further. This is the end of the road for this guy. That's it. Too bad. I'm disappointed. I don't like working on things and abandoning them, but I'd be stupid to continue with this. Well, thank you so much for watching the video. Here it is, put back together, and it's probably be sold off just as it is, partially working with one channel. In fact, it's all kind of written here already. So, yeah, that's the way it goes. Can't fix everything, and this is not in my bailiwick, as I mentioned before. So thanks a lot. I have something else in here tomorrow. I'm not sure what it's going to be. We will see. Bye.